Welcome back, everyone. Well, we made it through the dynamic routing protocols, RIP version 2, EIGRP, and OSPF. As you can see behind me, I do have a little switch lab here. But basically, we're going to talk about switching. And do we need switching? Of course we need switching. Everything within our networks are switches. We come from a world of hubs where we explained early in the course, hubs are just a complete disaster because they have one collision domain, one broadcast domain. You can only have half duplex, so not a good idea. We did have bridges, but again, we're limited with bridges as far as the number of ports are concerned. They're software based, so they're a little bit slower than the actual switches. Plus, they can only do one span entry per one span entry period for all VLANs. We're now, because the purpose of bridges was to segment, where switches bring in this functionality into the network. Not only are they faster because they're the firmware ASICs, everything is within the firmware, so things run a lot faster. We don't, a small switch, 24 ports, 12 ports, 48 ports, and the number keeps going up, 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 and up, the higher switches you get to. Also, you have full duplex coming out of each port. Okay, that means you can send and receive at the same time. So that increased that as well. Obviously, we do have the possibility of creating VLANs and VLANs when we get into it. But just an overview, VLANs is a logical segmentation of a local area network. Okay, so that's what VLANs are. Not only to mention, it brings the span entry as well for that switching loop not to happen. But you can create a span entry session per VLAN, where before you couldn't do that. And we also have switch port security plus a lot of other things, but switch port security will be the last place we will stop. Okay, because there's only so many things that you need to know. We'll talk about BTP and trunking and all these different things once we get to the appropriate lesson. But definitely, you do need switches. You do need switches in your infrastructure, whether it's per classroom, whatever it is, you need switches in your internetwork. Now, what switches do, they learn MAC addresses. Remember, switches are layer 2. They deal with MAC addresses, which are the physical address of each node. So they create this table called a MAC address table. Now, I have 3 computers here. They already have an IP address. If I go into the switch and I type enable and I do a show MAC-address table, I see that it's not populated. Let me maximize this. All right, it's not populated. There's no information going back and forth at this point. So it has not learned of any MAC addresses on the network as of yet. When communication starts going back and forth, switches learn, this is key, source addresses. Source addresses. In the IP version 4 world, once a switch sees a MAC address coming towards it, let's say on port 1, for example. All right, let me minimize this. Let's say PC0 wanted to talk to PC1. Once he sends out what? An ARP request, IP version 4, right? So once that ARP request gets to the switch will learn that source MAC address of that particular PC and assign it to that particular port, in this case F01. And then out of every other port, and again, this is a key word that you need to look for within your testing, it will flood all the other ports with this ARP looking for this particular, hey, who's the owner of this IP address? I need to know your MAC address. The appropriate computer or node would reply, and then it would map that particular MAC address to that port. Now you have a mapping of ports, of MAC addresses per port. Does that mean that now that our MAC address table is populated, that there's no more broadcast? Yes, there is. Yes, there is. Yes, there is. Just because it learned all these MAC addresses of these computers, great, no more ARP. But they're still broadcast because whatever he's doing here, they're going to hear noise over here. Because you have multiple collision domains, which is great, which you get that full bandwidth coming out of there. You're not sharing your bandwidth. This is what's called a private collision domain. But you still have only one broadcast domain. And certain IT individuals still do not understand that. Give you an example, real world example. Schools. All of you know me for saying the same thing because I've done a lot of schools. In schools, they, for whatever reason, maybe they're catching up now, I don't know, they don't use VLANs. They physically segment the network between, let's say, administration, whether it be the registrars, what do you call these people? The people that get you into school, the admissions, the counselors, account executives, whatever they want to be called, the executive director, the ED, admin people, okay? The people that run the school, that they physically have their own routers and switches and firewall and stuff like that. The students have their own routers and switches and firewalls and all that. So they physically segment. But you have, let's say, 50 classrooms. And you're an IT school, part IT, part, I don't know, medical, whatever's hot nowadays. All right, so you're running on the same VLAN because by default, all switches are part of VLAN 1. VLAN 1. Now I'm going to show you this real quick. Just you know what I'm talking about. Just so you know what I'm talking about. Okay. Show VLAN. See, we're all part of VLAN 1. All ports are part of the same VLAN. So if you can have 50 switches, a switch per classroom, we're all part of that VLAN 1. So no matter where you are in your campus, if you're not physically segmented from that VLAN 1, anything you do, it will create noise. And the example is the following. I was in a school at one point where, again, over 400 students. No, not such a big number, but it's okay. 400 people, right? 400 computers, actually, people doing things to it. And it's IT, partial, nursing, whatever. But what happens when the IT students start configuring DHCP? And we're all part of the same VLAN. Now, you have two DHCP servers with the same VLAN assigning IP addresses to the school. That's a problem. Because if somebody's doing a test and they're based on going out to the internet and now they just received an IP address from you, now they're no longer going to be going to the internet because you're not hooked up to the internet. You're not running NAT or anything like that. You're not even hooked up to the router that goes to the internet. So that's problem number one. Problem number two. Let's say the IT individual decides to run an image using whatever, Copernicus, Ghost, whatever software. I think it's called Copernicus. But I know Ghost is the most popular that, at least back then, everybody used. If you're running an image and the image is kind of big, you're going to bring the network down to a crawl. So you're going to have students that are suffering. They won't be able to take tests because the tests are on the network. Or they're very slow to do that. You're going to have instructors that are going to suffer because let's say they need to put in grades. But in order to get to the grade book, which is in a centralized server outside of their own local area network, outside their particular location, that's a problem. So some web-based application, let's say, you got to get to the internet. Now that image is causing a problem. So you can see where creating VLANs is something that you must do. So that's why we're going to learn how to create VLANs. But broadcast, that was the whole point of this analogy. Broadcast still exists. Word things that just because the MAC address table is full, the CAM table is full, and the MAC addresses of all nodes are there, that's it, there's no more broadcast. Well, you're mistaken. There is broadcast. It is your job to segment properly and to include those VLANs. use the VLANs because you can physically segment, but how about logically segmenting? All right, and when we get to it, we'll look at the advantages of doing VLANs. But this is what switches bring to us, this functionality. So I'm going to go ahead and ping back and forth. So now you can see how it's going to populate that particular MAC address table. All right, so I'm going to go ahead, and I already know the IP addresses. It's ping 192.168.100.2 and then 3. All right, so now once you ping that, remember it learns source IP addresses. So the MAC address table should be full now. Let me maximize this window if it allows me to. Okay, here we go. And now we see, because once we send that ARP, right, it mapped my MAC address, it saw my source, and then it went out looking for that destination. But when that source computer came back, it gave it its source MAC address. And that's how I learned. So now we know exactly where these 3 computers are at based on their MAC addresses. It learned it dynamically. So this is what the switches do. And as long as there's communication, sure, the ARP broadcast won't exist. It holds it for a certain period of time, or off the top of my head, I don't remember the number. Okay, but as long as there's communication going back and forth, and in a network, there's always communication back and forth, and you will have third-party software to be monitoring just in case there's a broken NIC card or something that's constantly sending out broadcasts, because that could be an issue as well. But that's why the segmentation of your school, of your business, is extremely important. And the best way to make use of that, not only physically, but logically as well. So switches, there you go, MAC address tables. All right, but that's not the only thing. I mean, we talked about that it brings spanning tree. It can do a spanning tree per VLAN. It can do switch port security. So now you're able to control how many and which computers or which nodes you're going to allow to that particular switch. All right, so you can create what's called VTP domains, where only the switches within the VTP domain will talk to each other. When we get to the lesson, we'll talk about VTP domains. All right, and does a switch need an IP address? I didn't need an IP address to get in it because I consoled in, right? Consoled in. But of course, if you have switches in your network and they're not manageable switches, what's the purpose? What's the purpose of having a switch that brings all this functionality and not taking advantage of it by having non-managed switches? So yes, if you're going to get a switch, get a managed switch. That way you put an IP address on the switch. Now we're going to learn shortly how to navigate through the switch, how to configure, put its administrative configurations. But yes, not only does it need an IP address so you can access that switch, so you can go in there and tweak the switch. And when I mean by you, I mean the IT administrator or the IT individuals. They're allowed to do that because you can do it just like the router based on username and passwords. But you also put a default gateway on the switch. Cisco Cisco requires that you put a default gateway on your switch, because if you're remote to your switch, and let me make a little clarification on what remote is. These are not remote. They're connected right there. But if this is VLAN 1, VLAN 2, VLAN 3, VLAN 2 and VLAN 3 are now remote to the switch because they need to go through the router to get back or to get anywhere. So they're like remote. But if you're actually physically or within a different broadcast domain, in order to access the switch, to go in the switch, you need to put a default gateway as per Cisco. So you need to remember that. And we'll do it when we do the configurations. All right, so you need an IP address so you can get into your switch. If you're locally, all you need is really an IP address. But if you are remote to your switch in a different broadcast domain, you do need a default gateway. So all these things are where switches are doing. They're doing a lot of work, but we definitely need them. Definitely, I remember working for another school where they had routers per floor. Not feasible. Very nice. Thank you very much. I appreciate that, but you're shooting yourself in the foot. Definitely financially. It's a switch per floor if you want, and just one router by the POP, right? The point of presence where the internet's going to be. Switch per floor, switch per classroom. However it is that you're going to do it, but definitely switches are what you need, because you can create access lists on switches as well. Now, I know there's a question out there and nobody's asking it, but they say, hey Lance, how come? Because in my company we use layer 3 switches, and that's very good for you. But in the CCNA certification we use layer 2 switches. You need to know about layer 2 switching, not layer 3. A layer 3 switch just has routing capabilities. For the CCNA, you don't need to be concerned about layer 3 switches. All you need to be concerned about is layer 2 switches. How to create VLANs, how to assign VLANs, how to manipulate spanning tree. What is a VTP domain? What is a trunk? These are the things, intra-VLAN routing, these are the things that you need to be concerned with, because switching is another 20% part of your grade. And guess what, ladies and gentlemen? When you go take your test, switching will be a simulation. I believe, from what I hear, all right, again, I get feedback from all my students that go take their test. It is just a bunch of show commands. But you need to know the show commands, which I will show you what you need to type to look at the information that you need to look at. All right, so I'll show you the main show commands that you need to know. So again, do we need switches in our network? Yes. Do we need to put IP addresses and default gateways on there? Yes. Why? Because we need to access our switches so we can configure them appropriately so our network will be efficient. And always remember the golden rule. 80% of all your traffic should be local to your segment. All right? I'll see you in the next session.